As we began the project, we realized there are certain challenges that we saw. For example, food insecurity and malnutrition, especially in the rural communities in Kenya. We realized that children are the ones that are um, facing the most risk. And so we realized that in order to address those challenges that were brought about by climate change, so when we talk about climate change, there's the extremities, there's the droughts and the floods, and so this led has over the years has led to a decrease in production of agricultural products, but also we're seeing that now there's also a challenge in terms of data. So there's not a consistent way to track these changes or the effects of these changes. And so that is what we're trying to address. We're addressing data literacy, we're addressing how data is being used and the culture around data. So we are debunking data science. Next slide, please. So what is this ecological farming that we keep speaking about? So ecological farming is a farming approach that emphasizes natural ecosystems and resource efficiency. So let me break it down further for you by saying that ecological farming is an approach of farming where you're working with nature rather than against it. So instead of relying heavily on, say, synthetic fertilizers or pesticides, ecological farming emphasizes practices that maintain healthy soils, conserve water, protect the natural ecosystems, and enhance resilience to climate change. So basically, it's a farming method that is the central thing about it is the natural ecosystem. Then integrated multi-tropics aquaculture, commonly referred to as IMTA, is a type of now ecological farming, but this type of farming integrates two or three different species that are cultivated together. So let's say, for example, our example here, rice cultivation and fish. So you take the same plot of land, the same rice paddy, but in that same plot, you're also rearing fish. So it's a kind of two in one because for the same period for the same uh, for the same plot of land, you're getting double the returns. But also, a key concept of IMTA is that the waste from one species then becomes the food for the other species. So it's a way of having a system that is serving itself. So it's a natural ecosystem of sorts that is also sustainable. And this type of farming has been in existence for many, many years. It's recognized by the Food and Agricultural Organization, and it's been adopted in China, Egypt, India, Indonesia, Thailand, Vietnam, Philippines, among many others, also in Africa, in some African countries. So, based off of studies, pilots that have been conducted, for example, Ideal did a use case, a pilot on a Hero irrigation scheme, but there's also been a pilot that's been done in Kenya at Kilifi. And these pilots have shown that this rice fish system requires 68% less pesticide and 24% less chemical fertilizer. Also, based on the fact that as I was describing what ecological farming is that you're stripping away all this artificial and foreign things that you're introducing to the soil or the water, but instead you're just using more natural ways of farming. So IMTA also has shown significant potential to address challenges related to food security, nutritional deficiencies, and climate resilience in Kenya. Next slide, please. So what is our solution? For our case, it's data science and integrating data science. So for our project, we undertook a countrywide initiative. We were mapping out suitable locations for applying the IMTA units. So this IMTA units, the crop that we focused and centered on is rice and fish and other indigenous vegetables. So after mapping out, then we came up with a machine learning model and used that to predict the potential benefits. So in terms of positive climate and health implications to the communities. Then we are further fine-tuning also our initial use case model, the one I mentioned, the pilot that we had conducted in Ahero, and updating it with news data as we're getting them from different partners, because our goal is to effectively use data science approaches to showcase the potential of ecological farming if it is adopted across the country. Because the point is we want to create a resilient system. We want to create an environment, an ecosystem where it is not susceptible to climate change or other external variables that could come in and destabilize this system. So next slide, please. How we did this, we took I'll call them the big three. So number one is big data. These are the different types and sets of data that we use. So for example, we got agriculture data, which encompasses rice yields and farming inputs. We did aquaculture, which is fish yields. And then we had health and nutrition data, which is stunting and malnutrition. And then we had data on the population and demographics. And I'll even put a pause here just to give a big shout out and thank you to the partners who gave us this data. We have Calro, who gave us the agricultural data. We have Kenya National Bureau of Statistics, who offered us the population and demographics data. Then we have the State Department of Irrigation, which now brings me to number 2, Geographical Information Systems. So State Department of Irrigation helped us so much to get the geospatial data that helped us now map out the different irrigation schemes that we targeted as potential areas for replicating the model. So 1, big data. Number 2, geographical information systems, commonly referred to as GIS. So here we got geospatial data using Google Earth Engine. But apart from that, we needed to actually map out the areas, and that's where now the State Department of Irrigation came in again. Then in line with that, there's weather and climate, so flood detection, vegetation cover, land degradation, and climate change monitoring. Now we took these 2 aspects, we put them together, and we trained a machine learning model using the data sets. And then this model is able to forecast key outcomes such as now crop yields, fish productivity, income improvements, and yeah. So allow me to put a pause there and invite our data scientist, Andrew Njio, to take us through what we came up with, take us through the platform. So let's now get into the meat of the webinar.
Thank you so much, Leah. I hope you can hear me. So my name is Andrew Karanja. Thank you. Thank you so much, Leah. So I'm the data scientist at Icon, and our platform, to give you a brief outlook, is that from what Leah has mentioned, you'll notice that key key among it is data. So what we do have is, before we actually came about to deciding how we are going to implement this, our first key task was to map out the stakeholders. So number one was to identify, do we have the data publicly available? Do we have partners whom we could look at, who would come in to assist? And then in terms of whether publicly available data is there, is it valid for use in our modeling? So these are some of the questions that were coming in terms of now our platform. So one key aspect is we looked at now rice irrigation. So integrated multi-trophic aquaculture begins with rice farming, then introduces fish, and then indigenous vegetables. So this platform, it showcases now what we can do with data, because this is a project that using data, we can be able to tell you that it's going to improve the impacts of the farmers. It's going to improve in terms of acreage, how big in terms of the size of land is going to improve in terms of climate. So that is I'll be showing, I'm giving a brief, and then I'll be able to share with you what the platform is all about. Next slide, please. So in terms of what we are looking at is, you'll notice that we used satellite data to get some of the climate data from it, climate and also weather data. So reason being, when you're looking at mapping, you have locations at different parts of the country. So you have irrigation schemes. So we have our platform is currently looking at 5 irrigation schemes. That is Ahero, where it began in Kisumu. Then we have Bunyala in Busia. We have in Migori, we have Lower Kuja irrigation scheme. We have Moya Tebere in Kirinyaga, and we have Bura in Tana River. So you will notice that when you are doing these kind of mappings, one key tool that was coming in is the Google Earth engine. Reason being, the satellite data that was coming in from there, it's accurate, it's specific to those regions. And aside from that, we are able now to use the Google Earth engine to pull more data, more granulated data, because you when you have data in that context, and it's actually based in Kenya, so you find that it's quite challenging to find granular data locally that deals specifically with weather and also climate, and also now floods as well. So you'll notice that that's where now Google Earth Engine comes in. And then we're able now to showcase on our platform the various irrigation schemes, the size of the irrigation schemes, and how suitable different irrigation schemes are towards implementing integrated multi-trophic aquaculture. Next slide. So, from our platform, this is data from the irrigation, the Ministry of Irrigation. So they were really key as partners to come in to provide this kind of data, because this data is not publicly available. However, it's really important that we're able to show what each irrigation scheme looks like and what we are looking at in terms of the regions, So these polygons showcase how we are able to show the impact. So for yes, I think that's it. I'll share my screen before we finalize, so that I can be able to show you to show you what we are looking at in terms of our platform. Before we come, let me share my screen. So this is our platform. This is what you look at when you come to the landing page. I hope my page has come up and you're able to see it.
Yes, we can.
Yes, perfect. Thank you so much, Leah. So when you come to the landing page, you're able to see a brief overview of what we are talking about, what integrated multi-trophic aquaculture as a system is. So we call it ecological farming because of the aspect of one, that it improves the soil because farmers are not able to use synthetic pesticides, and then number two, you're able now to get more value from a small piece of land. So when you look at now, when you look at our platform, you'll be able to see that a breakdown of the various irrigation schemes. So this is the size in terms of hectares, the size of our various irrigation schemes in terms of hectares, and then we have the impact based on now the county, the population of the various counties. So when you're looking at this, you'll notice that this is data from the Kenya National Bureau. There's an increase, so this is based now. So based on the model, you're able now to notice that there is an increase in terms of impact. There is an increase in terms of now and then we have now increase. So this increase is in various crops. So you'll notice that most of these irrigation schemes are rice irrigation. They conduct rice irrigation. So as a result, they don't get that much value from the piece of land. So looking at now the increase, so this is a projected increase of 45%. So based on number one in terms of rice, based on fish. So fish means that from that piece of land that did not have fish, you come from 0%, from zero, and then you get your value of that piece of land. And then we have now in terms of now the climate resiliency of the community. Then, so this is now a breakdown of how the project looks like. And then we have our partners. And then for our map, so anyone looking at our platform will be able now to click. So with the click of a button, you get to zoom in to the various irrigation schemes, and then you're able to see a percentage of how suitable it is as a scheme. So the suitability it's based on a rank. So it shows when a policymaker wants to implement this as a farming system, where would they start? Because that is usually the question. There's the financial question. So the financial question boils down to where do you start? And so we have a arrow here. So when you click, you zoom into the various irrigation schemes. So you have that. Then we have Moyatebere. Then we have along the Tana River, we have Bura irrigation scheme. Yes. Then yeah, from these you're able now. So this just gives you a breakdown. From it, you're able to see how suitable it is and whether implementation is viable. Then, so yeah, I think I'll stop sharing there. I think we can pull the slides up so that we do finalize on it. So yes. So why is this important? So you will find that most of integrated multi-trophic aquaculture as a system, it has not been implemented here in Kenya in its pilot phase. So data science comes in to assist in giving that value to the stakeholder. We are able to share with the stakeholder using data that number one, we are showing you the various irrigation schemes. We are showing you how suitable it is. We are showing you what is the impact. What is the impact when you introduce this crop? So from that, we're able now to grow. You're able to grow more, and you're able to waste less. And you're able now to boost your crop and the fish and the fish yields. Then using our system, you're able to perform mapping and we're able to identify the best locations. And then through the partnerships, through our various partners, our key partner being the farmer, because they are directly impacted by the work that we do. We're able to get to have the government coming in, and then we also have private sector. We have been having so many conversations with CalRO, with the irrigation, Minister of Irrigation, because those are the main stakeholders in terms of implementation. And then at the end of it all, the farmer is able now to grow nutritious food, to have a resilient ecosystem because rice and fish grow within a certain period, and then indigenous vegetables come in to substitute when the rice season has lapsed, and they can now grow the indigenous vegetables. Next slide. Yes. Thank you so much for your time. I believe that our project comes in to tackle the big parts of our country, and part of it is food insecurity and also malnutrition. And when looking at it, we have climate change, through agriculture. We're able now to reduce the impact on our soil. Then using data science, we're able now to show how ecological farming, the value, the viability of it, when a stakeholder intends to implement. And we are using mapping, we are using data, machine learning to be able now to show the climate and health impacts of our farming. Thank you so much. That was my time. Over to you, Leah.
Thank you for that, Andrew. Thank you so much for taking us through it. So, three things we came to do today in this webinar. First was to preview, to have a first look at our platform. And the second part, which is what we're now getting into, is to get reactions from our three speakers. So I will start by introducing the first speaker. Our first speaker is Irene Tiang. Irene is the founder and CEO of Mamlo Foods, which is a social enterprise that's transforming Africa's agri-food value chains through a micro-factory model. Irene, feel free to take the stage.
Hi, thank you. Thank you so much, Leah. Good evening. My name is Irene Etiang, as mentioned. And I'm grateful for this opportunity to share in this conversation. Personally, I come in with an understanding of an entrepreneur who is working with smallholder farmers, especially women smallholder farmers. And after listening to the presentation, I have a few questions, maybe like 2 or 3 minutes, and I'll be done. One is, yes, we are coming up with the inter-system, which is a very good idea for ecological, to support ecological farming. But I want to understand, is the platform or the tool going to only to be used by policymakers, or is it also going to be used by those at the grassroots level? Because those smallholder farmers that are in those that are using those inter systems are the ones that need to understand this data so that they are encouraged to see how they can maybe replicate it in other communities or other regions. Because if the tool only remains with policymakers, it means it will be hidden away from those that are meant to utilize the tool. And also the other thing is beyond yields and resilience, I mean modeling yields and resilience, farmers need to adopt the system, but for them to adopt the system, they need to see the economic returns. So it means if the intermodel cannot showcase the length of market linkages or other income kind of aspects of the system, then it means there'll be low adoption. That is, if we transition the tool to be a kind of platform that can be used at the grassroots level. Because if this system can be seen or understood with, let's say, farmer groups, cooperatives, and of course, county level officials, as well as government, the policy makers, I believe the farmers will be asking the questions of, oh, you want us to adopt the system or the inter-system, but how is it helping us economically? Because that is usually the main pointer when it comes to farmers. They want to see how is it helping them economically, then it translates into livelihoods as well as nutrition at the community level. The last but not least is usually, I speak this because this way because I am at the grassroots level with these farmers. So most of the time, you notice that you come up with models or systems or platforms that are showcasing or making farmers to look to be more of passive recipients of the technologies or the platforms. But I believe that there should be a technical shift between beyond having platforms or tools currently we are here talking about this, looking at the dashboard and all that. But it will be great if it can be transitioned to a level whereby these the real people that are going to utilize the systems are able to use it. Yeah. So that is for me, and yeah, that is basically the reaction I have on my end. But as it is, the system is enabling us, or the project has enabled us to really measure and understand the intersection between agroecology, nutrition, livelihoods, and it also has given me an opportunity to understand that you can actually integrate food systems and health systems as one. And I believe with that, we'll be able to really meet the African development agenda with such kind of tools and platforms, only if they can reach to the last mile. They can be distributed to the last mile. That is the cooperatives, the farmers, as well as the people at the county level. Thank you.
Thank you so much for your questions and for your reactions, Irene. Andrew, you can go.
Yes, thank you so much. Thank you so much, Irene, for your questions. And you raise some very pertinent questions. So first of all, yes, our platform, what we are doing, our platform is it cuts across both stakeholders. So both the implementers, that is any government, and also for the farmers. So the biggest challenge that has been coming in is how to be able to disseminate, because what we have needs to be understood by our farmers. So there is that challenge that we're also exploring how best to be able to share this with our farmers. Then in terms of the economic aspect, yes, we're able, from the data that we collected in terms of yield, we're able to tell the farmers that there is an increase in yield. So the platform, based on the modeling, we're able to show that there's this increase. Critical for it is, you'll notice that there's food production. In terms of food production, I shared that there is a projected 45% increase. So now 45% is a value. It's a value. So to break that down needs that's what we are now exploring, how to be able to disseminate this information to adoption of this system by farmers. And also in terms of now the toolings. So this tools needs to be understood by our farmers. So yeah, part of it is to share what we have done so far. We get feedback from people in those spaces, people like you, Irene, and which we get. So part of it is feedback, and also part of it is we get to improve on it. Yes, thank you so much, Irene, for your questions. I hope I answered them all.
Yeah, thank you. You did. Thank you.
Awesome. Thank you for the response. I see a hand that's been raised by a Brent Washington. Brent, kindly allow me to take your question after the expert's feedback. So I'll just give you the first chats once we're done with our experts. So allow me to welcome our second expert. So our second expert is Dan. And Dan Poku is a co-founder at VAD. He's also a data scientist, and he's building interactive data-driven solutions for climate resilience and public health across West Africa. Dan, please go ahead. Thank you for making the time.
Thank you very much, Leah, and good evening to everyone. Thank you for inviting me to this very important webinar. First of all, I just want to say this is great work being done by Icon and the team, Andrew and everyone. Haven't had the opportunity to see bits and pieces of this project a few months back, and to see the progress, the transformation of the project is quite amazing. The outcomes so far. Coming from a more technical data perspective, I think well, I don't have much to say on that aspect, but in the African ecosystem, what we've noticed or what we struggle with, less, well, technical capability is a concern, but getting the right stakeholders to buy in into a project, or a project like this, and see it from its pilot stage to its actual implementation and scaling is a major concern. And I think one thing I want to commend the team on is giving us that, for lack of a better phrase or better word, like a proof of plausibility, like this is possible. when we look at food security, we look at climate resilience. We've built this tool that can give us like an insight into what's possible if we take into consideration all the factors that or all the metrics that the models are predicting or the models are forecasting on. If we implement uh, this ecological way of farming for various communities across Kenya. I think just to re-echo certain sentiments or points that Irene raised, which I also share deeply in and was also thinking same, is the users of the tool. And I think Andrew has clarified that. The need to not lose sight of that if we are dealing with farmer cooperatives, how we are able to ensure that we outreach to them with this tool so that they are involved in the conversation, they are always in the loop. And in fact, that qualitative feedback can even help with updating even the models to a certain extent. And also, if we could have a clear pathway from this pilot stage to its actual implementation or use, we've created the vision, or we've shown people or stakeholders what can happen or what could be possible if we go ahead with this. But at the same time, we can also go ahead and even be very particular in showing them various pathways through which we can achieve these, achieve the results that we look forward to in implementing this or seeing this becoming real. And lastly, I from Ghana, where I'm based, I'm looking at the stakeholder engagement that and stakeholder engagements you mentioned in the presentation and how you collaborated with the various government agencies to come up with this tool. I must say, from our end, we have a lot to learn when it comes to data access, data sharing, and collaboration between government agencies and organizations that are building tools to help or to help with development in general. I'm very impressed with what's going on and in Kenya, and want to keep on. In fact, I'll be going back telling the story as well about how we could build tools like this as a form of building evidence. If the various public agencies open up to organizations like ICON to build tools like these. So yes, these are just a few comments on this project. And lastly, just to say, Andrew, well done for, I think I saw the first or the second prototype of the dashboard that you built, and looking at how it has transformed to this more interactive, more, I mean, it was just a short presentation, but I could clearly look at the potential impact. So I'm just praying with you and also rooting for you that this project can move forward from this stage to an actual implementation and use by the authorities, and also be a strong evidence to potential funders that we are just not cooking up stories, or we are not just coming up with things, but we are using advanced statistical methods to actually tell you that this is possible if you commit to it. Thank you.
Thank you so much, Dan. Thank you for your reactions. And the thing is, we're not just stopping there. We actually have a vision and a dream to do the same thing beyond Kenyan borders. So we've taken note of your interest, yeah? So our third expert, let me just welcome her. Our third expert is Soinato Lebo. Soinato is the co-founder and COO of RIA, which is an agri-tech startup focused on improving soil health for smallholder farmers through precision agriculture. Soinato, welcome.
Thank you, Leah. Thank you, Icon Data Learning Group, for welcoming me to this webinar. I would like to start by commending the team for the work that they've done. It's really amazing to see the bringing together of different stakeholders in order to make an impact in this space. And I feel that this project will be really key in bringing the aspects of ecological farming, climate resilience, nutrition, livelihoods, basically helping smallholder farmers in order to really gain insights on how they can grow more sustainably, improve their economic situations, and essentially have a sustainable way of living. So I would like to just commend the team for their hard work in bringing this project into reality. I have a few thoughts. Let me start by introducing Rhea, first of all. Rhea is a soil health management company. We are focused in helping farmers understand what's happening in their soils so that they can then go utilize their soil data to grow more profitably and sustainably. We do this by providing soil analysis solutions, such as on-site soil testing, and then we go further to give them recommendations, especially fertilizer recommendations, to help them understand exactly how they can improve their productivity. So I think what you presented today was very important in the challenges that we're currently facing in the agricultural space, as well as the climate space. And I had a few thoughts and questions to give to the team. So my first one would be around your thinking around soil data to provide additional data sets to your machine learning model and database, and how exactly you will be integrating this soil data into the platform, which stakeholders will you be engaging in order to bring this data into your platform, if you are going to be bringing more in-depth soil data into the database, and specifically now into the models that you're building. I would love to hear more insights on that. And then I also had a question in terms of the access to the API. So will there be access to the API post-project for the different stakeholders that you're engaging for this project? How will you go about disseminating the data and working with stakeholders to ensure that they all have access and that they can also utilize a lot of the learnings that you've been able to make in this project to also benefit whatever they're doing within their field. Around soil data, we've seen that access to quality soil data is very important in order to inform farmers on how they can actually increase their productivity. So I wanted to ask, how does the model and specifically the platform, since it's consolidating geospatial, crop yield, fish yield, and different types of data sets, how will you handle data quality issues such as missing data and noisy data or biased data sets to ensure that you have quality data on the database, to ensure that you're actually able to see improvements now on the ground and make informed decisions from the data that you have in the database. I also wanted to ask, what farmer education mechanisms have you proposed that will work with stakeholders to ensure that the learnings and the insights from this project will be reached at the ground level. I think Irene was had brought up a really good point where we do need to see the data and the learnings on the ground, especially for the smallholder farmers, and they need actionable insights to actually be able to take all of these learnings and have a contextualized understanding on how they can benefit from it. So I wanted to know more about how you'll be working with stakeholders to provide education, how you'll be training the farmers on using the database, and overall, how will this database benefit the farmers on the ground level? And I think my last point will be just to add on to that, the previous comment, how can the data help the different groups that you're engaging with? So to be more specific, how can a county officer use the database to decide where and how to support farmers? How can a cooperative utilize the data to see where they should be investing in? And more important, how can a donor identify high impact areas to ensure that the funding will actually be utilized at an optimal level on the ground? I think those are all my comments and questions for now. Sorry if there are too many, but again, thank you to the team for inviting me and for the great work that you've done so far.
Thank you so much, Soinato. Your questions are not too many. Thank you for that feedback. We truly appreciate it. Andrew, you can address the questions.
Yes, thank you so much, Ria. And listening to you speaking about how you're working with farmers and how your team is Soinato, yes. How your team is working with farmers towards collecting soil data, performing analysis and getting insights for the farmers. It's something that also happy about, and also specifically because capturing soil data, like the one we are using for our platform, is data from satellite data. So data from ISRIC, the International Soil Research Institute. That is, they host now that data. So it's more like a mean. So it's aggregated as opposed to granulated. So aggregated meaning that they conduct based on regions. They calculate a mean of that, and then we're able now to capture that, and that is what we use for our model. However, now you find that with the challenge with aggregated data is that it's not as specific as we would like it to be. That is where now your team we can also, this is throwing it out there, a partnership between ICON and your team to be able now to get much more data specifically for analysis from the farmers based on the database that you have as well, because I think it's one step that we've been looking at now, getting more partners to come in and identifying now where these partners can come in, because one challenge that we'll keep on saying and we'll keep on hearing is that there's a challenge of data, especially African-based local data. There's a big challenge with it. So getting to access that is where now partnerships come in, and I think Rhea can assist in terms of getting more granular data for the different regions based on how you work with farmers. So in terms of quality data, so quality data and noisy data. So part of it is you'll satellite data, you'll find that it's more specific. It's more specific based on geo coordinates. However, when you are looking at now data from for nutrition, data for population, data for health, you will notice that that data is now where now we find Kenyan-based data. So part of it is through our partnerships with Kenya National Bureau of Statistics, CalRO. That partnership is what we are leveraging on to now be able now to enhance the quality of the data that we have within our platform. And then in terms of the farmer mechanisms, so that is our next phase, where we are looking at how are we able to break down, because you can't keep sharing a single platform to a farmer, especially if it does not speak to them directly. So we're exploring ways of how to break down what we have on our platform into a way that the farmers can be able to understand. And also, part of this project is that we have been working with there's the pilot phase that began in Ahero that is now being implemented on the ground. And part of it is that we have partners there. We have a social impact organization based there. So that's how we intend to bring our expertise to the farmers. And then in terms of now getting this data to assist in decision making, in terms of the county, in terms of the funders. So in terms of now impact assessment. So impact assessment in terms of the project itself. So we use the rankings. So the ranks provide a level for each irrigation scheme. So in terms of where to start and which irrigation scheme would go next, and then so this is how we are exploring how our platform is assisting in terms of now speaking to the various stakeholders, that is whether it's county governments. So when looking at now for example county governments, we have Kisumu. We inform them that since this is a pilot, this is the impact that it will have for their farmers and also for the whole population of Kisumu. And then based on now these ranks, so the next irrigation scheme and so on and so forth. And then now for the funders is that based on the rankings as well, based on the rankings, the funder is able to identify which region will they can begin with. They can explore piloting the piloting IMTA units, because at the same time we have a challenge of finances, a challenge of where best to put the money. So based on the suitability by region, then we're able now to showcase, to show that this is where you can start. This is the impact that it will have with the farmers. This is how many farmers will start benefiting once you begin the implementation. Yes. I think I've captured all the questions from your end at Soinato. I hope I have captured all of them.
Yes, thank you.
Thank you so much.
Okay, thank you
thank you so much.
for that.
Sorry, Leah. Yes, I'd like to also thank Dan. Yes, in terms of the work, I believe Ghana is also a rice growing country, and they consume rice so much. So I think it's a project that can be explored on that side, and also thank you so much for your comments. I believe there's so much that needs to be done to get from analytics to implementation and then to adoption by the farmers. So I do agree with you that there is that journey that we need to walk. And yes, and thank you so much for your input. Right, over to you, Leah.
Thank you for that, Andrew. So now we are coming to the final stage of the webinar. So please feel free to raise your hand and ask your question if you have a question. So I'm throwing this to our audience. If you have any questions, reactions, please raise a hand and then I'll call you out. Yes, Brent, I remember you. Please go ahead.
Hello, my name is Brent. I'm also a data scientist. So I have some 3 questions to Andrew. I'm kind of curious about the short-term and long-term KPIs of the entire project. How do you evaluate or measure okay, first of all, what are the KPIs and how do you evaluate them, whether they are either short-term or long-term? Number 2, I have a question on the machine learning model used. The question is, does the model produce similar accuracy levels for different communities or irrigation schemes? For example, you are focusing on different irrigation schemes. Maybe there's a Hero, there is the other ones in Coast. So I believe that these communities or these irrigation schemes, they have different social dynamics. Maybe the communities are different, the farming systems are different. How do you measure the accuracy of these models to get uniformity, right? So I think I'll do with those ones first.
Thank you so much, Brent.
Yes.
Yes, and to respond to your first question about KPIs, so for the short-term KPIs we are looking at getting traction. So the first aspect is to identify this platform is there. So we get as much traction as it's possible for people to be able to know that this is what exists. So by people, I mean stakeholders. So that is the short-term KPI, because once that is done, then we've laid the foundation. So looking at now the long-term KPIs is now getting implementation of it. So getting to that journey. So as I mentioned, and as what has been mentioned by the previous speakers, is that getting from analytics, from a dashboard, to stakeholders being able to understand what this is going on, and from there providing funds for implementation. So the long-term KPI is that adoption of this system comes in, and with that, now we have more metrics. We're able now to tell. So currently, what we are doing is we are predicting. So in terms of whether we're able to predict in terms of time series analysis. So in terms of the weather, and then coming into now the specific yields. Now we do a regression to be able now to see production how it moves. So looking at that, so all these are hosted within the implementation piece, because once that is done, that is where now the real impact will come in. and that is now for the long term. So, and then the further long term, it will be now the impact now on the soil. So impact on the soil, and then impact of now the nutrition, because once production comes in, then consumption comes in. Then consumption results now into nutrition for the kids, nutrition for the farmers, and nutrition for the community as a whole. And then in terms of accuracy levels, so the model currently was trained with data from all the regions. So there are assumptions that were made that when building this model, because there are different. We have Bora in Tana River that has different weather patterns as compared to say Mwea in Kirinyaga. So the model currently was trained on the data holistically, and that's now where we are now looking at now in terms of accuracy, in terms of the accuracy levels. Yeah. I hope I've answered your question, Brent. Thank you.
Awesome. Any other question, comment, feedback, or reaction?
I think I want to give maybe a final feedback or comment concerning modeling and the accuracy, the accuracy of the models and all that. I and going back to comments from previous speakers, I think the I think what I've noticed, especially in projects like these, initially I thought that modeling would be the most difficult aspect, but over time I've realized that the quality of the data, as mentioned by previous speakers, the aggregation or even the granularity of the data, and all matters concerning the quality of the data becomes paramount. And you realize that in the grand scheme of things, the time spent on modeling, sometimes it surprises people that they get to know that, oh, it just takes a few hours and you are done with modeling. But every other aspect concerning the feature engineering and the quality of the data is a chunk of the problem. So I look forward to any documentation or any any documentation you put out there, especially on your data or your quality assurance processes. And I believe that could also help us understand maybe certain approaches or assumptions you made in the modeling process. So I'm not sure that can be exhausted in this webinar or this call, but if in the near future, Andrew, you can invite us to maybe another meeting or session to take us through your quality assurance processes, that would be exciting, so that we could provide deeper feedback on the accuracy of the models. Yeah, thank you.
Thank you. Thank you so much, Dan, for the feedback.
Thank you for that, Dan. Any other feedback from our audience? feel free to ask any questions you may have.
Hi everyone. My name is Clinton. I'm also a data scientist. So my question is, how do you make sure the models, the model predictions are transparent and easy to understand, so that the farmers and the policymakers can trust them and confidently act on them?
Thank you so much, Clinton, and thank you so much for the work you do at REA. Yes, to respond in terms of transparency, I will respond this with what Dan has just mentioned in terms of data quality. So, majority of what the model is relies on what data we have. So, as I mentioned, the majority of our data was either by our partners or majorly by our partners, because Google also counts as our partner, and also our government partners. So you will notice that now, when coming into a sit down with policymakers, so part of it, part of what we will leverage and what we are leveraging right now is that we gave them the benefit. We took the data that they shared with us. So I'm giving an instance of the cultural data that we have about fish, the data that we have about nutrition, about population. That is data from the government, our public sector partners. So we go back to them. We tell them that you gave us data, and from the data, this is what we can tell you about the data. So that forms a big part of how to get transparent about the accuracy, because you will tell them the technicalities. We use this algorithm, but at the bottom line of it is, what data did you use? So if you mention that we used your data, then we are able now to get that background, that you trusted us with your data, and with that we're able now to tell you from that data that this is what you can do. Yes, I think that's how best I would answer that. And so in terms of breaking down the model to farmers, so I've spoken about our public sector stakeholders. So in terms of to farmers, I think it's one of the challenges that I'm still exploring myself. How best to break down data science to be understood, because I think that is also one of the questions that come into you, Clinton, in terms of how you able to do analytics of the soil. So yes, I would say that is an ongoing process of how to be able to break down, to explain how accuracy happens, how the model does, what it does. Yes, I hope I've answered your question, Clinton.
Yeah, sure. Thank you. You've answered my question. Thank you for the insightful presentation.
Thank you so much.
Awesome. Thank you for that question, Clinton. Any other questions before I invite our team lead?
Yes.
Go ahead, James.
Yeah, I have a quick question regarding how accessible are. I would like to know the methodology used to collect the data, is it possible to be accessed with such information? If it's from the ministry or if it's from a civil society expert organization, is it possible?
Thank you so much, James. I think I think Leah can speak a lot to how our conversations with the stakeholders came about to now getting the data. I think Leah, are you comfortable sharing the?
Yeah. Thanks, Andrew. So in terms of access, and this is also something that Suinato had brought up. So how will we involve different stakeholders in participating both in helping refine our model and thereafter then integrating it into their programs? So for now, we are fine-tuning our model, making sure it's working the way it is supposed to work. And then that will take different angles because there's also stakeholders that we hope to engage to get better data. For example, for soil data, if there's organizations that we're looking to reach, like to get data, granulated data on soil. So there's different partners that we're still looking to onboard so that we can refine the model better. But further than that, once we've finished working on it, we will then get into the next step where we could offer access to the APIs. But then this will be in the next stages, and it will be basically you'll get access to the platform, but also you can get access to not necessarily the data. I will not promise that we can give you the data because of the agreements we had with the partners, but we can share with you the outcomes or the tools, APIs in future to integrate into your platforms or your projects. Yeah, so it is possible, but it is in the near future.
Okay, thank you.
Awesome. Any other questions, feedback?
Yeah, I have a question.
Go for it, Maribo.
I'm here. I'm Joy's friend. I'm Soinato's friend. So for this data, do you guys just focus on the fertile sides of Kenya, or is it the whole of Kenya, or how does it work? Because I know there are some areas that people are seasonal farmers, and there are some areas that are mostly throughout the year. So
Okay. Andrew, are you comfortable taking that?
Yes, I can take that. So we began with exploring rice irrigation schemes because part of it is there is the infrastructure already in place. So that's the reason why we'll I think, yeah, and that is a good question, Maribo, and thank you so much. Yes, we began with those regions because there is the system in place. So there are the irrigation schemes, there are those canals, there is a little less financial burden to a stakeholder who would like to come in to implement IMTN. So that's the reason why we're exploring these the rice irrigation schemes first, and then looking at now in terms of production. So you mentioned that there are farmers who grow seasonally. So part of these, and the reason why it's called ecological farming is because the goal here is to have an all year round production. So this being that they'll they'll grow rice, and then they'll harvest rice and sell. So that land remains bare for some period of time. So during that period of time, is it possible to have a different crop growing there? Then we come to now the indigenous vegetables. So here we have rice growing during the rainy season, and then we have indigenous vegetables being farmed during the drier seasons because they are more resilient to the sun. So we have that, and then we have the fish now being grown now within the period. So you have an all-round production. That's how we envision in terms of how ecological farming looks like, and how implementation would look like, and how the impact it would be to the farmer.
Okay, thank you.
Okay, awesome. I'll just double click on what Andrew was saying. The reason why we did the irrigation schemes is because one, there's data available, and the practice, like the irrigation of rice, is already ongoing in comparison to other areas where there's no data or a means to get to that data or get to that community. That's why we started with the irrigation schemes that we did, as we did, but it's in the pipeline. Maybe as part of the next steps, we could explore getting to the smaller farmers. Yeah, any other questions, feedback, so that we can end the meeting? Okay, I'll take the silence to mean we are all satisfied. Allow me to welcome our team lead, Zedi Misiga, to just give us some closing remarks.
Much do we have?
Yes, sure. You have 5 minutes.
Okay, because I also wanted to give a few reactions before I just gave my summary. I know there's always the aspect of does more data points lead to improved accuracy or robustness of the model? Yeah, someone was speaking to this, and it's not only that. There are also different things to look at. Like whenever we are adding more data points and sets, there are the aspects of quality. Is it relevance? Does it make our model more representative? And at the end of the day, can it help to capture variability and help reduce overfitting? So just mentioning that there were also quite a couple of things in terms of data sharing that was coming up. And these are conversations that we are still having even at national level. And I was happy to see that even for the experts that are already working with data, this is something that we struggle with. Similar to what is happening within the organizations, we realize that at national level, at Kenya currently, we're still working on a data strategy. And that means that all the data sharing agreements and MOUs are still on more of like a third-party basis and are not like guided by some specific national framework at some level in point. So that was great contribution, including on how to make sure that the model is transparent and easy for stakeholders to understand. One of the things is that by having this meeting, we're also ensuring that we are having different voices through even our model development phase, and even as we continue to review it and deploy it, it is this kind of participatory kind of approaches that ensure that indeed we are addressing the real concern of the primary stakeholders, and also ensuring that there's ownership. And yes, I do agree with the expert, I think Dan, was mentioning the importance of also just working on clear documentation and communication to ensure that people can see that the methodology is transparent, and then that the data that was used to build the model can also be verified and tested. Aside from that, I'm very honored that you guys took your time, particularly for the experts to join us today, and also to share your sentiments with us. And you've really raised like some very important points that will help shape our next step. Even at this stage, as IDL where we are at, we are actively exploring like different ways to collaborate with more stakeholders, and like the conversations were going, especially with the farmers themselves, because collaboration is at the heart of everything we do, beginning with our name, which is issue-based collaborative networks. And I also agree. That it's important that we start looking at this from an economic kind of metric. It is crucial, yeah, and I know this will be appealing to most stakeholders, particularly for people who want to inject investments. And this is an area that we are also eager to focus on, even at this earliest phase of this work. So once again, thank you so much for organizing this meeting. I know that the team might not have said it, but this is work that started last year in September, and I'm genuinely pleased to see it come full circle. And also want to extend my deepest appreciation to our partners, particularly GPSDD and the larger consortia that was also working on IMTA. Thank you all for the partnership and for your continued contribution. Have a good evening. Thank you.
Thank you so much for your remarks, Zedi Misiga. Thank you so much for coming to the webinar. Thank you for participating. Thank you for listening. Thank you for contributing. Thank you for just a big gratitude to all of you. And let's keep in touch. Feel free to reach out to us in case you have further inquiries or questions. Our email address is connect@icondataLearning.org. So I believe that's it for today. Have yourselves a lovely evening and see you next time.